Hello everyone, welcome back to the online session on dynamics of machines. In the previous session, we have learnt about the different types of damping and the derivation for the damped free vibration, means differential equation for the damped free vibration. At the end of the derivation, I told about three conditions on the damping ratio factor based on the damping ratio, that is zeta. If zeta value greater than 1 and zeta value lesser than 1 and if zeta value is equal to 1, so what is the condition? So in today's session, I am going to explain about the three conditions based on the damping factor. So we will start with the first condition, that is zeta greater than 1. If the zeta value is greater than 1, we call it as overdamped system. Such type of system we call it as overdamped system. So under that system, the motion is not a periodic. Why? Because the mass movement is a very slow process in such condition. So that's why the motion is not a periodic. Means in overdamped system, the roots are real and negative. Real and negative. Now we know that the expression from the previous derivation, that is x is equal to a1 into e to the power of minus zeta plus square root of zeta square minus 1 into omega n into t plus a2 into e to the power of minus zeta minus square root of zeta square minus 1 into omega n into t. So this is the differential equation that we have derived in the previous session. So based on this, a1 and a2 are the arbitrary constants. So to determine the arbitrary constants, I am going to consider some initial conditions. So those initial conditions are x is equal to x naught at t is equal to 0, x dot is equal to v naught at t is equal to 0. So if the mass, if the system is displaced at a certain distance by a certain distance, so at that situation we have considered some initial condition. So that is x is equal to x naught at t is equal to 0 and x dot is equal to v naught at t is equal to 0. Now I will apply these conditions in equation number 1. I will apply those initial conditions in equation number 1 so that I can find out the a1 and a2 expressions. Now apply the condition, first condition, that is x is equal to x naught at t is equal to 0. So now applying the condition to the equation 1. So in place of x, I'll write x naught. This is in the form of e power x, right? So e to the power of minus zeta plus square root of minus zeta square minus 1 into omega n into t. As per the condition, t is equal to 0. So if I put t is equal to 0, the whole term will become 0. So e to the power of 0 is 1. So a1. Plus in the same way for the a2 also, it is a2. So the final expression is x naught is equal to a1 plus a2 from the condition, that is x is equal to x naught at t is equal to 0. Now I will apply the next condition, that is x dot is equal to v naught at t is equal to 0. X dot is equal to v naught at t is equal to 0. But here I have x. Here the condition is saying x dot. So differentiate the expression with respect to time, that is dx by dt. So after the differentiation, you will get x dot is equal to a1 into e to the power of minus zeta plus square root of zeta square minus 1 into omega n t into minus zeta plus square root of zeta square minus 1 into omega n plus a2 into e to the power of minus zeta minus square root of zeta square minus 1 into omega n into t into minus zeta minus square root of zeta square minus 1 into omega n. So next V naught is equal to a1. If I put 0 in place of t, it will become e to the power of 0. So minus zeta plus square root of zeta square minus 1 into omega n, plus in the similar way a2 into e to the power of 0 minus zeta minus square root of zeta square minus 1 into omega n. So in the next step, from this expression x naught is equal to a1 plus a2. So I can write it as a1 is equal to x naught minus a2. So in place of a1, I will write x naught minus a2. Why? Because the whole terms will be in terms of a2. So I can find out the a2 value. So x naught minus a2 in place of a1. Now multiply x naught minus a2 into this factor and you will get v naught is equal to x naught into minus zeta plus square root of zeta square minus 1 into omega n plus a2 into zeta omega n minus a2 into square root of zeta square minus 1 omega n minus a2 zeta omega n minus a2 into square root of zeta square minus 1 into omega n. Means, see here I have written x naught minus a2, right? X into this factor, again a2 into this factor. So you will get this step, just multiplication. Now from this step I have plus a2 into zeta into omega n and minus a2 into zeta into omega n. So I have cancelled the term. The remaining terms are v naught is equal to x dot into minus zeta plus square root of zeta square minus 1 into omega n minus, here I have a2 into square root of zeta square minus 1 into omega n, here also I have minus a2 into square root of zeta square minus 1 into omega n. So it is minus 2 into a2 into square root of zeta square minus 1 into omega n. Just simplify it. Then after this I want a2 value. So take out the a2 in the left hand side and shift all the factors towards right hand side. So you will get a2 is equal to x naught into minus zeta plus square root of zeta square minus 1 into omega n minus v naught divided by 2 into omega n into square root of zeta square minus 1. So this is the expression or the value for a2. In the similar way, we can find out the a1 value also. Here I have considered a1 is equal to x naught minus a2. Suppose if you consider a2 is equal to x naught minus a1, you will get a1 value like this, v naught plus x naught omega n into minus zeta square plus square root of zeta square minus 1 whole thing divided by 2 into omega n into square root of zeta square minus 1. See, I have not written square here. So in exam also, while deriving or while writing the condition, you may get the chances to miss out the square or some brackets or some plus minus sign and all. You have to be very careful regarding each term in the condition. So this is the values for a1 and a2. For the differential equation of the damped free vibration, I have applied the initial conditions, that is x is equal to x naught, x dot is equal to v naught at t is equal to 0. So from this I have reduced the step to here. So from this I got the values a1 and a2. So this is about the overdamped system. Now we will see the critical damping system. In critical damping system, the damping factor value should be equal to 1. When the zeta value is equal to 1, so the system will call it as the critical damped system. And for such system, the roots are real and equal. For the overdamped system, it is real and negative. But here the roots are real and equal, and the radical becomes 0. Why? Because the zeta is equal to 1, so the radical becomes 0. The roots, that is alpha 1 and alpha 2, that is equal to minus omega n. So this is the important condition. Alpha 1 is equal to alpha 2 is equal to minus omega n. Now the general solution with respect to critical damping, that is x is equal to a1 e to the power of alpha 1 into t plus a2 t into e to the power of alpha 2 into t. Now in place of alpha 1 and alpha 2, I can consider minus omega n, right. So after simplification, we will get x is equal to a1 plus a2 t whole term multiply with e to the power of minus omega n into t. So this is the expression or the general solution for the critical damping, that is zeta is equal to 1. Now we are going to find out the arbitrary constant values, that is a1 and a2. So determine the arbitrary constants a1 and a2, the initial condition as per your previous condition, x is equal to x naught and x dot is equal to v naught. Now here I have x, in place of x write x dot, then a1 plus a2 into t is 0, so only a1 into e to the power of minus omega n into t, again t, it will 0, so e to the power of 0 is 1, so the remaining term is x naught is equal to a1. Now differentiate this with respect to time, so you will get x dot is equal to a1 plus a2 t into e to the power of minus omega n into t into minus omega n plus e to the power of 0 means minus omega n into t means it is t is 0, so e to the power of 0 into a2. So you will get, in place of x dot consider v naught, so v naught is equal to minus a1 omega n plus a2. So v naught is equal to, in place of a1 I can write it as x dot, since x dot is equal to a1, so minus x dot into omega n plus a2. So a2 value is v naught plus x naught into omega n. Now just substitute the values of a1 and a2 in equation number 1, so you will get this final expression. Just substitute the a1 and a2 value in equation 1, so you will get the final expression. Now we will see the third condition. Okay, now the next system, that is overdamped system, zeta is less than 1, means the condition, if zeta is less than 1, the system is said to be underdamped system, and the roots for this system are imaginary and both the roots are complex conjugates. The given condition of the roots are alpha 1 is equal to minus zeta plus I into square root of 1 minus zeta square into omega n. See, this should be square root of 1 minus zeta square, because in the previous condition we have considered the zeta square minus 1. Since the condition is different for this imaginary and the complex conjugates, the roots of alpha 1 is minus zeta plus I into square root of 1 minus zeta square into omega n, and alpha 2 is minus zeta minus into I into square root of 1 minus zeta square into omega n. Now we know the general expression, that is a1 into e to the power of alpha 1 into t plus a2 into e to the power of alpha 2 into t. In place of alpha 1 and alpha 2, write the given roots, that is alpha 1 and alpha 2 minus zeta plus I into square root of 1 minus zeta square, and alpha 2 minus zeta minus I into square root of 1 minus zeta square into omega n. So after this step, so we will get the common factor e into e to the power of minus zeta into omega n into t. Here also we get e to the power of minus zeta into omega n into t. Just take out the common factor outside. The remaining factors are a1 into e to the power of I into square root of 1 minus zeta square into omega n t plus a2 into e to the power of minus I into square root of 1 minus zeta square into omega n into t. I have just taken the e power as a common factor. Now just observe this. This is in the form of e power I theta and e power minus I theta. So as per the standard condition, we know that e power I theta is what? Cos theta plus I sin theta, and if it is e power minus I theta means cos theta minus I sin theta. So here in place of theta we have 1 square root of 1 minus zeta square into omega n into t. So just write in this form e power I theta x is equal to e to the power of zeta into omega n into t as it is. Then a1 this is in the form of e to the power of I theta. So that is cos theta plus I sin theta. So cos theta plus we have a1 because this is a1 into e to the power of I theta. So we have to multiply with a1. So a1 into cos theta plus a1 into I sin theta. I sin theta in place of theta square root of 1 minus zeta square omega n into t. Then plus a2 into e to the power of minus I theta. So minus I theta means cos theta minus I sin theta. Same thing, a2 into cos theta minus a2 into I sin theta. I have just reduced to the condition of e to the power of I theta and e to the power of minus I theta. So next we will get e to the power of minus zeta omega n into t. Here group the function in one side of the same trigonometric function, a1 into cos of 1 minus zeta square omega n into t, here also a2 into cos of square root of 1 minus zeta square into omega n t. So the common factor is cos of square root of 1 minus zeta square into omega n t. The remaining factor a1 plus a2. In the same way, a1 minus a2 into I into sine of square root of 1 minus zeta square omega n into t. Just group the trigonometric function, cos function one side and sine function one side. Next, for this the remaining factors, the arbitrary constants a1 plus a2 and a1 minus a2. Consider in place of a1 plus a2 c1, in place of a1 minus a2 into I, it is c2. Just put this in the next step. So we will get the expression like this. Then in place of c1 and c2, I have considered the values. c1 is x sin phi and c2 is x cos phi. Why? Because here I have cos of 1 minus square root of 1 minus zeta square omega n into t, right? Since this condition is holds good for the periodic motion. So the remaining trigonometric function is what? The sin phi. Now for c1 it is x sin phi and c2 it is x cos phi. Just apply this condition in place of c1 and c2. And also we have one condition here, omega d means damped natural frequency is equal to square root of 1 minus zeta square into omega n. Here I have 1 minus zeta square into omega n. Here also I have square root of 1 minus zeta square into omega n. So in this place I can consider it as a omega d. So the expression will become x is equal to e to the power of minus zeta omega n into t into x sin phi into cos of omega d t plus x into cos phi sin of omega d t into t. Sin omega d means damped natural frequency into t. Observe this condition, here x is common and these terms are in the form of sin a cos b cos a sin b. It is nothing but sin of a plus b. So your final expression is e to the power of x is equal to e to the power of minus zeta omega n into t into x common factor sin of phi plus omega d into t. It is in the form of simple harmonic motion, right? X is equal to a sin omega t. So that's why we say this condition is in the periodic motion like underdamped system. So this is the expression for the underdamped system. You have to remember all these three conditions. If damping factor is greater than 1, it is overdamped system. roots are real and negative. Damping factor is equal to 1 means it is the critical damped system. The roots are equal, real and equal. Damping factor is less than 1 means it is the underdamped system, and roots are imaginary and both the roots are complex conjugates. So, related to the underdamped system, we have a small concept related to this, that is logarithmic decrement. Logarithmic decrement. So, logarithmic decrement means it is the natural logarithm of the ratio of any two successive amplitudes on the same side of the mean position in an underdamped system, which means I will just show here. If you consider like this, so this is your maximum amplitude and this is the minimum amplitude, right? So the two successive ratio of the amplitude, which means if it is x1 and x2 and x3 and x4, x1 by x2, two successive ratio of the amplitude on the same side of the mean position, on the same side of the mean position under underdamped system, underdamped system. So for that we call it as a logarithmic decrement. And for this I am going to consider the condition of the underdamped system, that is x is equal to small x is equal to capital X into e to the power of minus zeta omega n into t into sine of phi plus omega d into t. So here in this expression I have already told it is in the form of simple harmonic motion, right? So if you get the maximum amplitude, your function sine of omega dt plus phi should be equal to 1. So then you will get the maximum amplitude. So if it is 1, so your x will be capital X into e to the power of minus zeta into omega n into t. As per the definition of the logarithmic decrement, the two successive amplitudes, the ratio of any two successive amplitudes. So I will consider x1 and x2. x1 is the maximum amplitude with respect to time t1 and x2 is the minimum amplitude . Okay, so this is x1 and this is x2, right? So x1 this is the maximum amplitude with respect to time t1 and x2 is the minimum amplitude with respect to time t2. So x is equal to x capital X into e to the power of minus zeta omega n t1 for x1. In the same way for x2 it is t2. As per the definition, x1 by x2, so if we modify this in x1 by x2, we will get here xx will get cancelled, shift this to numerator, so you will get x1 by x2 is equal to e to the power of my zeta into omega n into t2 minus t1. So after simplification, x1 by x2 is equal to e to the power of zeta omega n into t2 minus t1. So this is the equation 2. Now we know that t2 minus t1 is nothing but the time period. So for that we know that the condition t is equal to 2 pi by omega d, since we are discussing in the damped free vibration. So damped natural frequency 2 pi by omega d. We know that omega d is nothing but square root of 1 minus zeta square into omega n. So it will become 2 pi by square root of 1 minus zeta square into omega n. Now just substitute this Tp value in place of T2 minus T1, because T2 minus T1 is nothing but Tp. So we will get x1 by x2 is equal to e to the power of zeta omega n into 2 pi by omega n into 1 minus zeta square. Here we have omega n and omega n, just cancel this. So you will get this factor e to the power of 2 pi zeta divided by 1 minus zeta square. And as per the condition, we know that x1 by x2 is equal to x2 by x3. So that is equal to, in a common factor, xn by xn plus 1, because here 1 by 2, 2 by 3, 3 by 4. So n is nothing but 1, 2, 3, 4, and n plus 1 means adding 1 to the existing number. So 2 plus 1 3, 3 plus 1 4, like that. So that is equal to e to the power of 2 pi zeta by square root of 1 minus zeta square. In general, we can write it like this: e to the power x n divided by x n plus 1 is equal to e to the power of 2 pi zeta by square root of 1 minus zeta square. Now take natural log on both sides. So you will get ln of x1 by x2 is equal to 2 pi zeta by square root of 1 minus zeta square. That is nothing but delta. That is the delta. Why delta? Because as per the logarithmic decrement, natural logarithm of the ratio of any two successive amplitude, natural logarithm of any two successive amplitude, so that is the ln of x1 by x2 is equal to 2 pi zeta by square root of 1 minus zeta square. So that is the logarithmic decrement condition. If the system executes n cycle, if we got the n cycles, so the expression will be delta is equal to ln of x0 by x1 is equal to 1 by n into ln of x0 by xn. So we will use this while solving the problem. Here x0 is the initial amplitude and xn is the amplitude after n cycle. So this is a very small concept related to underdamped system. In your examination also, they will ask the derivation of the logarithmic decrement up to 8 to 10 marks. Almost in all the question papers, it is like a constant question. In the previous year question paper also, you will get the question on the logarithmic decrement, derive the expression for logarithmic decrement for 8 to 10 marks. So this is about the logarithmic decrement. So this is the theoretical concepts related to the damped free vibration as per the syllabus. Now based on this condition, like formulas what we have got from the theoretical concept, in the next class we are going to solve the numerical problems based on the theoretical concept. Thank you.